So now we are going to solve some more quadratic equations. And I have here 2x squared equals 26. Typically, you want to put this in quadratic form with all the terms on the left-hand side and 0 on the right. But in this particular example, we don't have to do that. And why is that? Because we are missing the middle term. We are missing this term right here. There's no x term. So in this particular case, we can go ahead and use the square root property. But before we do that, we're going to divide out by 2. So when I divide out by 2, this is 1, so it gives me x squared. And 26 divided by 2 is 13. Now at this point, I can take the square root of both sides. So I'm going to go ahead and do that. As long as you're doing it to both sides, that's allowed. This is the part where a lot of people mess up, because when they take the square root of x squared, they just say x is equal to the square root of 13. And actually taking the square root of x squared is not just x. It has to be absolute value of x. And the reason is because x could be negative. So if x is negative square root of 13, you square it, you're going to get positive 13. And so, and then you take the square root of that and you get square root of 13. So anyway, the point is you have to have the absolute values. And that just means that x could be positive or negative square root of 13. So don't forget that part. Typically, you're going to have 2 solutions. Well, not always, but often when you're taking the square root of both sides like this, it's going to be plus or minus. Okay. So the solutions are x equals square root of 13 or x equals minus square root of 13. Now over here, we want to get it in this form, so we're going to add 5 to both sides. And that's going to give me 5x squared plus 12x plus 5 equals 0. And I'm going to go ahead and check the discriminant, because I have a hunch that this doesn't have solutions, but I'm not sure. So using the discriminant, that is going to tell me if I have solutions or not. So b squared minus 4ac is equal to, well, b is the middle, the coefficient on the middle term. So b equals 12. And then I'm going to square that. And then I'm going to subtract 4 times a, which is 5. And then times c, which is also 5. And it looks like it does actually have a solution. I'm glad I checked. So because I thought maybe these numbers were pretty big, but if you'll notice, this becomes 144 minus 4 times 5 times 5 is 100. So it's the discriminant is 44. And since it's positive, then we know we have 2 solutions. And we can use this quadratic formula now. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And minus b is 12, so that's going to be minus 12 plus or minus, we already calculated this, right? This was 44 over 2 times a. A is 5, so that's going to be 10. And we're going to simplify that. I can take out a factor of 4, but when I take the square root of 4, I get 2. So inside, I'm factoring it as a 4, but when I take it out, when I take the square root, I get 2. So that's what I'm doing here, minus 12 plus or minus 2. And when I took out that factor of 4, I had 11 left over 10. And now the numerator can be factored by 2 and also the denominator. So bringing out that factor, I'm going to take out the 2 from each of these. So I'll be left with negative 6 plus or minus square root of 11 over 5. So my 2 solutions are x equals minus 6 plus square root of 11 over 5, and x equals 6 plus or minus. Or I'm sorry, minus 6 minus 11 over 5. So here we have plus or minus, this is the plus, and here's the minus. So negative 6 plus square root of 11 over 5 and minus 6 minus 11 squared root of 5 are my solutions.